Hello.
Good morning slash evening.
I guess it's good morning tomorrow and good evening yesterday.
Yeah. So, how's things going?
Well, I'm affecting the changes that you gave in the thesis,
Hmm.
and I see your point, and hopefully I've made good on them. I won't ask you if you've had a chance to look at them because I'm changing a lot of it as we just before this
Yeah,
meeting.
yeah, yeah.
Um, I'm still working on the cosmetics for the second plot that you asked for, but it should be ready to go here by tonight. I'll be going home and doing more futzing.
Okay.
The data is just over halfway done regenerating. So there's about 470 skirms left for all runs.
Okay. And that when did you set them going?
I set them going kind of late last night. It was about midnight, I think.
Okay. So it's been going like 18 hours or something.
Yeah, something like that.
Okay. All right. So it'll be done tomorrow.
Yes. The last run, the last iteration, I projected it would take about 18 hours, but it finished somewhere near 24, I think.
Okay. Okay. So since um we can't write the sort of main so there's a chunk of results we can't write about yet and the conclusions. So we should make sure everything else gets as close to being done as possible.
Hmm.
Um, so I think the if you make the changes in chapter 2 that I went through, that gets us, I think, close to having that, fairly complete and ready to go.
And I think I'd say about 85% of it's been affected, I think.
Okay. And then let's see what I need a note of. Oh yeah, so and then there's the yeah, at the start of the results chapter, that's where we want to put in our um the graphs where we're showing the effect of P, sigma zero, and sigma delta, and um discuss those uh discuss those results in the way we were doing yesterday and summarize the basic trends. I actually was just about to send you an email with the link to the Jamboard that we used, which I realized. There we go. Can you check you got that email and make sure you can access the Jamboard?
I got it, and it looks like I can access it.
Excellent. Okay, good. Yeah, so I think it was just the first page where I listed this was just for the first of the 6 plots, but um you should go through and write it in a way that makes sense to yourself.
Hmm. I don't remember these other plots
No, no,
off the
no.
top
I
of my head.
used that Jamboard later on for a couple of my other REU students. So, um, let me here, I'm gonna write on the thesis just to make a note of the structure of the results chapter. Um, um, so we okay, yeah. So I didn't add this explicitly. Um, but we should show the JL and KSIM priors for all the distributions we're running.
Oh, yeah, yeah. I think
So
you do.
basically, corner plot with that just shows JL and KSIM for the uniform distribution from the correlated distribution from Savannah's distribution, all overlaid on top of each other. I'm going to add that to the final point in my list. Sure. Okay, so first thing in the results chapter is we want to show the reader that given the tools we've described in the last chapter, we can demonstrate why it's important to do this whole study. Right, it's important to get values of the surface parameters that are physically motivated, and we show that by showing that they make a difference, right? If you get the wrong values, you're going to change the results, and yeah, so it's important to get values that make sense physically. So we make that argument showing the tests we did for varying the three parameters, and discuss those tests, discuss the trends that we see in the relative importance of those three parameters. What was I going to say? There was one thing I was going to say. Okay, it may come back to me. Okay, then, so once we've established that, then we show that we reproduce the correlations between surface and symmetry energy. Sorry, surface symmetry energy and bulk symmetry energy, J. That's the Danielowicz plot, and you've pretty much got that written. So a point to make here is that previously we have not, like, those correlations when we've been choosing the surface parameters randomly and uniformly, they haven't included these correlations, but these correlations are physical. So
And what do you mean by our previous work? Do you mean the
the group's
pre-Josh?
previous work, so the paper, the set of papers that started with Balliet, Ross, and me 2020, and then Preston, me, and Ross 2022 probably, and then me and a load of people in 2022, and then the PRL paper with David Sang 2023. Those are there are four main papers where we have developed and extensively used our cross model. And in all of those cases, we're using uniformly distributed surface parameters. So those are the things we're improving on in this work.
And should I have a string of references on that concluding line?
Yeah, well, I mean, those papers need to be mentioned wherever relevant, as any.
But also, but like, yeah,
certainly
mention them where necessary, but here as well, like when
Yeah.
we talk about the previous work, there'll be a bracket, and then
Yeah,
I see it.
yes, that's right.
Okay.
Yeah. Oh, yeah, now it's come back to me what I needed to explain. We can probably do this in the results section. So we should so our main results are going to be so main results part 1. Yeah, first we need to so main results, first thing we need to make sure we're doing is telling the reader what the distribution of surface parameters is when we're not using SINEM or mass splits. what's the third thing that we're comparing to? And then I think the first part of the main results will be so for the uniform distribution and the correlated distribution of JLK sim. And for each of these, so we're going to show two corner plots. And one of them is going to be the one that has sig 0, sig del, and the NCC, PCC, MUCC, NP, PP, MUP. And then the second one is the one where we're going to have the delta M, delta R pasta divided by delta R crust and delta M pasta divided by delta M crust. Okay, so discuss what effect on the crust quantities fitting the data to semi-infinite nuclear matter has, and how big the effect is. And remember, the bottom line is that the reader wants to know I know this is wants to know if they should care about, obtaining physically motivated values of these surface parameters. Right. Is it worth it? Are we going, if we're going to do this, then it had better be that it makes a difference to what we predict for the cross properties. If it doesn't, there's no point. Any old distribution will do if they both give the same predictions for cross properties. Okay, and then main results part 2, we're going to do this is the comparison of the uniform distribution of surface, or the let's call it the prior So the one where, P is selected at random and whatever the non-fit distribution is of surface parameters. So that's versus sin m versus fitting to masses of finite nuclei.
Oh, I see. Oh yes. So this will be the three distribution.
Yeah.
Okay. Sorry, I was lost there for a second.
Yeah. So, and same two plots as above. I'm thinking maybe, well, no, we'll leave it like that. So before we get to main results part 2, there is something that we haven't told the reader that we need to know, that the reader needs to know, and that is what are these mass fits to finite nuclei? They've sort of come in out of the blue. Do we mention that elsewhere in the methods?
No.
Okay. So we need to tell the reader how those mass fits are done. So how the mass fits are done. Right, and so all we're doing is, what Savannah was doing is calculating the nuclear masses of all measured isotopes. Of all isotopes for which and we're doing it using the compressible liquid drop model. And then for each value of J, L, and K sim, we fit those calculations to the measured mass values. The sort of it's 2000 or so using a least squares fit. And when I by those calculations, I mean we fit sig 0 and sig del. So this is giving us another physically motivated way to obtain sig and sig del from JL K-sim. And then in the main results, one of the obvious things to ask is, are the parameters obtained via the semi-infinite nuclear matter and the mass fits Are they consistent with each other? And how do their predictions for crust properties compare? Okay, so I think that is the full outline of the results chapter.
I have 3 questions when you were in your flow state, if now's a good time to ask them.
Yeah, absolutely.
So in the second corner plot where we're doing the calculations for those 2 ratios,
Yeah.
would you like me to include the surface tensions in there as well? Or do you just want like a small corner plot that would end up being 2 by 2?
You can include sigma 0 and sigma delta. I think it's useful to see the correlations. We should also see the correlations between JL and KSIM and sigma 0 and sigma delta.
Should I throw that onto the early plots then? So because you want JL and KSIM for each distribution anyways. Should I just throw sigma 0 and sigma delta on there as well? Or should it be separate plots?
I think it should be separate plots so as not to, because otherwise you're presenting the reader with a lot of information in what, like the initial purpose of showing the JL and KSIM distributions is so the reader knows what our priors are in JL and KSIM. If we add to that, if we start adding on crust results calculated in 2 different ways, and like that's not, we're then moved on to talking about something else. So it's just I often have to play around a bit to figure out the best way. Like, so basically what we want, like the results we want to show are essentially the results we want on our corner plots for each distribution are JL, KSIM, sigma 0, sigma del, NCC, PCC, mu CC, NP, PP, mu P, delta M pastor over delta M crust, and delta R pastor over delta R crust. So they don't, obviously, it's going to be overwhelming and difficult to read to put them all on the same corner plot. So we have to split them somehow. And the question is, what is the most sensible way or the most readable way to split them?
I probably don't have the agency to say this, but I think I would like it if it was just set up initially and to say, okay, you're going to see a series of plots, and each plot will correspond to this distribution, and then it's just a series of 2 corner plots that are small side by side of what will always be sigma 0 and sigma delta, and then there'll be a 3rd or 4th box that's like NPP and then NP, and then you just do that all the way down and just keep it consistent. So you do many small ones.
Yeah, I think I like that. So you would do yeah, so as you said, the sigma 0 and sigma delta are the common factors. So I actually think what you said lends itself to 4 plots, right? So you can have the JLK sim sigma zero, or sigma 0, sigma delta JLK sim, sigma 0, sigma delta NCC, PCC, MuCC, sigma 0, sigma delta NPPP, MuP, and sigma 0, sigma delta delta R pasta over delta R crust, delta M pasta over delta M crust. So you've got 4 plots. They're all similar sizes. So yeah, I think that I think is a good way to go. So let's do that. Okay. Other questions?
Oh yes, the other two. So for the mass fits point, do I have access to the papers that I'll probably have to cite within my literature on the drive?
Um, the let's see, did hang on, just give me a second. So here, let me share this with you. Oh, it is shared with you. Okay, good. So the main thing that'll help with that bit, I guess, is Savannah's presentation. Which it looks like you have access to, but I'll copy the link into the chat. Where'd the chat go? Make sure you can get that. Did you get that?
Oh yeah, sorry. I'm looking at it right now.
Oh, okay. Yeah. So you can see on slide 4, there's the link to the data, the mass data, the so-called atomic mass table. And that Yeah, if you click on that, that takes you to the table, but it also takes you to the relevant. It also shows the relevant references. So you'll see it'll take you to a text window or file. And there's the two AME atomic mass evaluation papers. So those are things to reference for the actual data we're using. For the actual like fitting masses to a liquid drop model, the link I've just put in the chat is the original like paper on this that's been cited 3,000 times, which is mad.
I feel like I know the name Sviateki. I feel like
Yeah,
I've seen that knocking around.
yeah, you almost certainly have. Um, okay, yeah.
And I have one more point, but I'm just going to quickly save that.
Yeah.
Okay. Within the SAV mass fits point, you mentioned the 2000-ish skirms that are included with that analysis, but the amount that we're currently using are 1100 just for time and like similar sample size purposes. Is that like worth mentioning in the paper, or is it just well enough to say,
No, you say yeah, so you need to discuss yeah, so I'm going to insert this point. We need to tell the reader order of magnitude how many models we're calculating for each distribution. So basically we're always doing of order 1,000. So that's what we say. It doesn't, there's no that then that then sets the sort of statistical error. So
and those were
the basic rule of thumb is that if you're sampling something n times, then whatever you get for the mean or the median or whatever will have an uncertainty of plus or minus the square root of n. So if we're using 1,000 points, it's plus or minus 33. Basically, 33 is that the square root of 1,000? Yeah, yeah,
It'll be on the order at least.
yeah. Right. So you can see that the more samples you get, the progressively that gets smaller relative to.
God, that was some quick math. It's 31.
Okay. Well, I mean, 30 30s are 900. So you bump up for a bit from there and then.
Wham bam.
Okay. Any other questions?
Those were all the points that I came up with when you were riffing.
Okay. Excellent. And any questions at the moment about the just going through and updating all the chapter 2 based on my notes?
I don't think so. It was all fairly clear and very intuitive to follow. Like it took me a second to see what I needed to do, but once I started doing it, it became very clear that was the very proper way of going about it.
Right, right.
I would
Excellent.
expect I'll continue working on the changes to chapter 2 as the data continues generating,
Yes,
and
yeah,
I'll
yeah.
email you when I've affected those chapter 2 changes.
Yeah, and I can then go and edit. I did have one quick question just to pay attention to when you're again, this is a point about scientific language. The you should try to avoid language that is sort of equivocating. So is like not being like unassertive language. It occurred to me just because I noticed at the very end of chapter 2, you have the sentence, upon successful conclusion of this group's process, we will have seemingly linked the surface potential to JL and Ksin.
Sorry, I'm just parsing that.
Right. So that is like so you I mean that implies we may not have, that it may just be, you know, appearance. You know, when you say something is seemingly this, then you're casting aspersions as to whether it is actually that.
Mm-hmm.
Right. Does that make sense?
Yes, yes.
Right. So and you don't need the word. It's like upon successful conclusion, we will have linked the surface parameter to the JL and Ksin. I mean, that's we will have. There's no maybe about it. So we don't need. You'll find that there are a few words scattered throughout that are just not. They add doubt where there is no doubt, and they're sounds like we're beating around the bush a bit when we're not. So always try and think how to state things directly.
Mm.
Okay, good.
All right.
All right, I'll let you get off, and I will, as always, send you the recording of this.
Awesome. Thank you. And I'll get to work on back to chapter 2.
Yeah, and let's meet same time tomorrow.
All right, sounds like a plan.
Excellent. All right. I'll talk to you then.
Talk to you later. Have a nice day.
And you.